Welcome back to this lecture series on signal and system. So in this part of this video, we are going to be looking at the elementary operations of signals. So in other words, some textbook or some material might just call it signal operations. So when we are talking about the elementary operations of signal, basically they are of three types. And number one, the first one we have time shifting. And then number two, we have time scaling. And number three, we have the time reversal. So now let's take a look at them one after the other. So now let me start from the first one, time shifting. All right, so when we are talking about time shifting, basically it has a mathematical representation, which is when we have x of t. All right, so let me give you, said if it is time shifted by TO, the time shifted version S of t is represented by, all right, so what I'm saying is that if we have is a signal like this x of t, exactly, so if it is time shifted, so we are going to be having something like this. It's going to be looking like this. That's x of t minus t naught. Now once we are having something like this, if it is t naught, so if you have your t naught to be positive, so let me first of all make that clear. So you have to take note of this. So if t naught is positive, so what it means is that the signal will be shifted to the right. So the signal will be shifted to the right. And if t naught is negative, that means the signal will be shifted to left or to the left. Exactly. So now let's look at one example. Now let's take this as a signal. So if we have the signal, and then here we have our x of t, and then here we have our t. Now for this particular signal, now if we have, now let's say we have our, in the first scenario, we have our t naught to be equals to, okay, so let me call this is 2, minus 2, and let's call this plus 2. So don't forget we are talking about time shifting. So if our t naught in the first case is 2, and then in the second case we are having our t naught to be equals to minus 2. I hope you can see that. So now this is the main signal itself. So if our t naught is 2, that means we are going to be having x of t minus plus 2. Exactly. So, and in doing that, we are going to be having x of t minus 2. And don't forget what I said, that when t naught is positive, the signal is going to be shifted to the right. Exactly. And when it is shifted to the right, there's another thing that you need to take note of, which is that means it is delayed. So you can say that means the signal is delayed. All right. So now once it is positive like this, like I said, the signal will be shifted to the right. Now if you are to redraw the signal, we are going to be having something like this. Now it is shifted to the right by 2, so it's going to start from here. And this will be 4. And this will still remain. So right, what we are having here now is a representation of x of t minus 2. Exactly. So now let's go to the second one. So when our T naught is negative, and don't forget I said when our T naught is negative, the signal will be shifted to the left. So let's write out the initial signal. So that means our x of t minus 2. Exactly. So that means we are going to be having x of t plus 2. So if you are to draw this now, so it's going to be looking like this. So this is the initial signal, and now that it is the t naught is positive, it will be shifted to the left. So we are going to be having something like this. So here is going to be minus 4 and 0. So this is a representation for when of x t plus 2. So this is it on time shifting. You just have to take note of this this here. This is a mathematical representation for time shifting, and you have to take note that when t naught is positive, it will be shifted to the right, and when t naught is negative, it will be shifted to the left. So there's one thing you need to also take note of is this negative will be there when you are bringing it t naught, the value of t naught. Make sure the negative value is there, especially even in both cases, exactly, so that once you bring it in here, it becomes positive. Exactly. So don't make a mistake of when you have a function like this or a signal like this, x of t plus 2, because you are seeing a positive here, you might think that, okay, it shifted to the right. Exactly. So it can be a little confusing. And that when you see x of t minus 2, then since it is negative here, it should be shifted to the left. No. Just understand it. This is it. What you are replacing here is t naught. Exactly. This negative will still remain. Exactly. So the only time it will turn to positive is if the value of t naught itself is a negative value. I hope that makes sense. All right. So that is for the first one for time shifting. So now let's look at time scaling. All right. So that's the second one. Time scaling. So basically, what time scaling is, the time scaling is of two types. So when we are dealing with time scaling is of two types. Number one, we can either have compression or expansion. That's a compression or expansion of the signal. All right, so now let's look at, let me use this example to illustrate what time scaling is all about. So if you have a signal like this, all right, so let me make this thing better. So if you have a signal like this, and so let me draw the signal itself. Okay, so let's say this is 2. This is going to be minus 2, and then we are having our, okay, so this is 2, this is minus 2, we are having here to be x of t. Exactly. So if you are to compress the signal, we are going to be having it look like this. Okay. So if you have to compress it, it's going to be looking like this. Now, what will make it different from the initial one that we are having is, let me redraw this. All right, so it's looking better like this. So now once it is compression, remember then it will reduce by whatever value it is. So let's say, so if you are having it as x of 2t, so that means we are compressing it by 2. So that means this is going to be 1, and this will be 1. But the amplitude will remain the same. So I didn't indicate that here. So if the amplitude here is maybe 4, the amplitude will not be affected. It will still remain so the amplitude will still remain, it will still remain the same. Exactly. So what will just change is our T here. So this is for compression. So, but if it is for expansion, so let me draw that. So if it is for expansion, so the representation will look like this. If you're having it to be x of t over 2, exactly. So in this time around, this is the original signal. This is the original signal here. So here we are going to be having, so you multiply by 2, this will be 4, and this will be minus 4. The amplitude will still remain the same. So this is what time scaling looks like. So it's basically the compression or the expansion of signal. So this is more like the representation of what time scaling is all about. All right, so now let's move to the last one, which is the time reversal. So for time reversal. All right, so for time reversal, if you have a signal which is x of t, so if you want to indicate it as time reversal, you are going to be having it as x of minus t. So once you have x of minus t, it's showing that this is a reversal of a particular signal. And what does it actually mean? That means it's simply when you mirror a signal. No, I'm trying to do it. So let's say we have a signal. Let me draw a signal. Let's take this to be a signal. And then, so let me draw the signal itself. So, taking this to be a signal, let's call this s of t. Now, if I should mirror it along the y-axis, so it's going to look like this. Okay, so let me make it better. So in this that we are having here is going to be our x of minus t. Because what we are having here, if you should mirror it, that means if you should flip it along the y-axis, that means if you should flip it along the y-axis, you are going to be getting this, exactly. So that's what time reversal is all about. So you just now, it involves the mirroring of signal, exactly. Once you mirror a signal along the y-axis, in most cases, then if from the x of t, if x of t is the signal itself, it becomes x of minus t, and this is what it's going to look like. So it could be anything. You can have a signal that looks like this, So if I should mirror this, then it will look like this, exactly. So once something like this occurs, that means time reversal has taken place, exactly. So basically that's what we want to cover in this video. The elementary signal operation, there are three. We have the time scaling, time shifting, and time reversal, and those are the things that we've actually look at in the course of this video. So I hope you find this video helpful. If you do, please give it a thumbs up, and if you have any question or any doubts, do leave them in the comment section below. And with that, I'll see you all in the next lecture under signal and system. Thank you.